Hello everyone, welcome to our presentation. I'm Redwan and my teammate Tahmina worked on the COCO, detecting emotion shift in conversation by common sense knowledge. There are some tasks that some of them have done individual and some of them as a group. Presentation overview consists of warm-up, introduction, related work, solution overview, data analysis, analytics lifecycle, tools, timeline, limitation, conclusion, and finally references. Warm-up. Before deep dive into the concept, we need to be same page and have a same approach according to this topic and know how much importance of the NLP emotion detection and emotion shift in conversation. Kahneman introduces two characters that animate the mind, System 1 and System 2. You can see System 1 and 2 in this picture. System 1 refers to intuition and instinct of conversation, and it's an unconscious, fast, and automatic pilot. And System 2 refers to rational thinking and refers to take effort, slow, logical, and this means System 1 is easier for human and machine to understand and find the meaning of the sentence and the conversation, and we know how to do system 1 reasoning with deep learning, so we only need to figure out system 2 reasoning, and this means we need to let's bridge the gap between system 1 and system 2. Sometimes system 2 is hard for human to catch it. And according to the popularity of using conversational artificial intelligence research, emotion recognition has received much more significant attention, and humans express emotion by using context and common sense. Therefore, emotion detection relies on both of them. Context refers to the lexicon-based method, and common sense refers to the natural conversation, includes several distinct pragmatic variables that have a direct impact on the flow of dialogue, such as argumentation logic, interlocutor viewpoint, and so on. And common sense is the basic level of practical knowledge and reasoning, and considering everyday situations and events that are commonly shared among most people. For example, it's okay to keep the closet door open, but it's not okay for the fridge because the food inside it might go bad. And therefore, common sense is essential for AI to understand human needs and perception. For example, humans know the door for the fridge is different from the door of a closet. And uh, path to common sense is different. For example, symbolic common sense graph, neural common sense representation, reasoning with common sense, and construction challenge data set, right? And before force, sorry, sometimes we think that by adding more deeper layer and more layer to model can extract a comment, but according to this sentence we can find the right answer, correct answer, and we can find the true path. You don't reach the moon by making the tallest building in the world taller. And there, in emotion detection and NLP, there is pre-trained language model that refer to a training model with one task to help it form parameters that can be used in other tasks. And the concept of pre-training is inspired by human being. For example, we transfer and reuse our old knowledge of what we have learned in the past and to understand the new knowledge. And pre-training model technology inspired, the name of pre-training technology inspired from Sesame Street um, program that there is different pre-training model technology, but the almost three important of this algorithm is Elmo, BERT, OpenAI, GPT. But we go through Roberta because of these reasons. Roberta refers to robustly optimized BERT approach, and during pre-training BERT use to object, mask language modeling, and next sentence prediction. But there is some challenges and problem that Roberta can overcome those by training the model longer with bigger batches over more data and removing the next sentence's prediction objective, training on the longer sequence, and dynamically changing the masking pattern applied to the training data. And for common sense knowledge graph, there is different sources for this concept, but we go through the Comet. Um, as you can see, generic knowledge base is almost near in comparison with the other sources, but there is some problems and some challenges that we encourage us to go through Comet instead of generic knowledge base. And common sense knowledge help to machine to understand the difference between the word in different situation and extract that sense behind each sentence. For example, you as a human, when you hear fast food and quick food, according to the concept and related work, you can understand the difference between the fast food and quick food. And Comet learned based on the atomic and there is different parameters such as reaction intent of a speaker and of the sentence, and this concept used in to emotion detection and emotion shift in conversation. And for this purpose, there are different paper and method existed, for example, such as dialogue, RNN, cosmic, context-dependent sentiment analysis, and so on. But we inspired from dialogue, RNN, and cosmic, and we changed some parts from cosmic, and we consider the combination of dialogue, RNN, and cosmic, and change some parts and um, add some cell to existing layer. Solution overview. We go through the data analytics lifecycle. The first step is discovery, and it refers to our investigation for the accuracy of previous method for emotion detection in conversation, and we catch that one reason for not recognizing emotion correctly during conversation is not paying attention to emotion, and that emotions that have overlap, and also don't pay attention to emotion shift in conversation. And because emotion detection and emotion shift is important to sensitive NLP assisted business, such as legal trials, interviews, e-health service. Therefore, we decided to go through this. Second step is data preparation. Mm, we inspired from Dialogue Earning and Cosmic, and use the same data set. Um, and almost there are the famous data set for NLP. I mock up, as you can see, emotion, different emotion according to the number of sentence is almost imbalance, and there is no there is no same distribution for different emotion. and you can see the heat map for this data set, and you can see according to the different color, this is not a balanced data set. And the second is MRNLP, and you can see again it's an imbalanced data set, and this is a heat map for MRNLP. And third one is daily dialogue, and the status of this is worse in compare the previous, and the last one is melt. The third step is model planning, and we consider grow, but there is a different recurrent neural networks such as LSTM, RNN, but GRU is faster and easier to train than the LSTM counterparts. And this is a supervised learning algorithm and multi-class classification. And model building, this is our model, and this is the major difference with the cosmic and dialogue RNA. And model building, we gather all these in this picture, and this is a data set that by using the Roberta and Comet feature extraction is happened, and the normalization happened on the input, and this is a decoco consists of grow and dropout happen in the hidden layer, and attention apply because there is a imbalanced data set, all of the data set is imbalanced, and ReLU for the activation for the last layer, and this is like softmax to produce a y-hat loss function, and again because this is a bidirectional model, and backpropagation occurred, and Adam optimizer happened, and this is our model. And this is our different implementation for each part consists the this is the COCO model, training model, and hyperparameter, and so on. And this is a model evaluation. Model evaluation, as you can see in this picture, finally, after that forward and backward propagation happen, finally accuracy function applied to measure the accuracy of the model, and you can see this is the accuracy for different data set. And because this is those are all of data set are imbalanced, F score is better measure in compare with the recall and accuracy and so on, and therefore apply the F score to the result. You can see this is a F score, and a communication result. Finally, you can see the result of the COCO in different data set and compare with the cosmic and dialogue RNN. And we offer a model that you can use, such as a cosmic and dialogue RNN, and out of one of the important application of this model is a commercial chatbot. You can use in a commercial chatbot for example, e-health and like this. And this model can be used for two modes, in case where only one person is uttering, and another is that two or more people are talking to each other, and we are supposed to follow the whole flow of a conversation. And this is tools that we go through them, and this is our timeline. And there are some limitations for us, such as lack of professional computer to create model, and lack of memory space to extract all features, and lack of time to investigate other methods related to normalization and loss function. And but we can get a good result in compare with the existing model. And conclusion, this model uses attention on context and can examine the ability of proper word relationships with other, and which is a great help to discover the hidden common sense and emotion and for the machine in conversation. And this is our references. Thank you for your pay attention.